Hello! This video is part 1 of a series of videos designed to teach you more advanced concepts of assembly modeling, continuing the elevator mechanism from the basic assembly modeling series. If you've ever spent hours chasing broken mates after a design change, this video is for you. Let's get started. Each subassembly follows the same design intent and mating principles, as with the main stage described previously. Notice each subassembly is organized with its own folders for hardware and other components as appropriate. To build the top-level assembly of the elevator, the first subassembly should be the main stage. With a new assembly file open, I will use the Insert Components command to add the main stage at the origin. When adding mates to constrained components within an assembly, you have many options available. In Solidworks design, each part and assembly has a default origin with default planes that pass through it which can be leveraged for mating. Because all of the subassemblies were designed with the origin in mind, we can take advantage of the fact that the default right plane is at the center of each. Using Windows Explorer, I'll add the Stage 1 subassembly. The first mate is a width mate between the bottom tubes of each. Notice, I have made the right planes of the top-level assembly, as well as each subassembly, visible. Since the main stage subassembly was inserted at the origin, the top-level right plane and the right plane of the subassembly are coincident. I could use either one to center the Stage 1 subassembly. The best choice is to use the right planes from each subassembly, thereby following the design intent more accurately. I'll hide the top-level right plane. Holding Ctrl key down, I multi-select the two right planes and add a coincident mate. Now the Stage 1 subassembly moves within the main stage as it should. I do not need to see the right planes any longer, so I will select them in the Feature Manager design tree and hide them. Click the drop-down from the eyeball on the heads-up display to control the global visibility of objects in the graphics window. Now I will add a coincident mate where the Stage 1 subassembly sits on the bottom tube of the main stage subassembly. When I expand the mates folder, it is the last one added to the list. This is an important, or key mate, as it represents the bottom position of the main stage. I'll rename this mate accordingly. Then, right-click and add it to a folder that I will name Key Mates. This is a great way to keep track of important mates in your assemblies. I will use drag and drop to reorganize the mates folder so the Key Mates folder is at the top of the list. Following this same process, I will add the carriage subassembly, starting with a width mate between the carriage and Stage 1, and a coincident mate with the right planes of the same components. A coincident mate is added that represents the bottom position of the carriage. This mate is renamed and added to the Key Mates folder as before. Now, when I expand the Key Mates folder, I can easily select each mate and suppress it from the pop-up menu to see the movement of the components. Selecting both mates and unsuppressing them activates the mates and returns the components to their bottom positions. Lastly, the cross-brace subassembly is added then constrained with a coincident mate between the right planes of the main stage and the cross-brace. Two concentric mates on the appropriate holes fully define the assembly. By considering design intent and planning your models around the origin, you can take advantage of the default planes and ensure your assemblies function as they should. Thanks for watching. If your first robotics team is ready to level up, get free SolidWorks design software, training, and resources to power your team's success, and equip your team with professional tools used by real engineers.